Good morning, everyone. Welcome back. For today, our last lecture regarding C. The goal is moving forward to C++ next week. But before that, next lecture, the goal is to do a full review in preparation for the midterm. As we mentioned before, your midterm stop here. Your midterm is basically everything that we have reviewed and today. So programming with C, Java, paradigms, concepts, that's it. C++ is going to be included in the final exam. So next week, C++. Today, we need to finish, hopefully, with our last topic with programming with C. Now, we were talking about data structures. In particular, we talk about linked list, and you already know linked list. Really, the only reason for talking about linked list is two things. Number one, we need nodes. And nodes basically are this group of two things, two variables. We make this example with an integer and a pointer to a node. And this gives us the opportunity to work with structs. In your data structure class before, probably you use classes, the class node. In C, we do not have classes, but the closest thing to that is a struct. So hopefully you have the opportunity to review the source code that I shared with you in the slides. And well, there is a struct, and the struct have a value, and that value can be whatever you want, a name, a number, an object later, and a pointer. A pointer to what? In this case, for the linked list, a pointer to the next node. And then the second thing that we did is, well, if we're playing with pointers, why not work with the heap, dynamic memory, Malloc. And well, you remember, you have a Malloc, do not forget the free, clean your space. We work with the struct, we have pointers inside, and then we start playing with the Malloc. And at the end, we get this node connected with another one, connected with another one, and this one to null, the representation of null ground. This is what we did. We already reviewed the source code for this, at least the important one. Now, if we want to follow a good programming approach, well, instead of having all the code, as I showed you before, we need methods. For the methods, hopefully you have the opportunity to copy paste all of this and get familiar. Important things that I need you to remember. Number one, the libraries that we're using. So far, we're working with this. The library for the print and scan. The library for the Malloc and free. And there is another one that maybe you need for your homework that we mentioned before. This library string that have methods that you can use to work with strings. You remember the equal method in Java? Well, here you have string compare, a method. Or you have string copy as a method. And so on. Those methods that you can maybe found in a program and they start with string str, they are going to be in that library, the string library. Very, very important, guys. all the libraries in C, they have this .h in the name. Later, in the future, we're going to use include. And you are going to have a library string without the .h. Maybe you are using a particular IDE to work. And if you do this, probably work. But I need you to be aware, this one is the library in C. This one is the library that have these methods. This one is a library, but it's a library in C++. Yes, it's the same name. They only remove the .h. Yes, that is the only thing that happened. But this one have inside a class. So if you are looking to use these methods in your programs and you include this library, it's not going to work because they are two different libraries. They contain two different things. Remember, string.h, a library in C with those methods. String without the .h is not the same library. Moreover, it's a library in C++ and have a class inside. Several of the IDEs, several of them, they are C compatible. You are working with C or with C++ and the compiler understands both. So just be careful with this. Good? Now, moving forward, structs. We review structs and something that hopefully you remember. Outside of the methods. You create your structs before start defining methods. Moreover, the semicolon. Do not forget the semicolon. The first time that you have closing curly bracket and also a semicolon, both together, that is the end for the struct definition. Then a main. You need a main. And void or int. If you put int, you return something, the return telling the operating system that nothing happened, everything fine, zero problems, return zero. Now, inside, if you review this, something that I need you to visualize during your exam, everything that is going to happen here, from the point that you read the name of a method, you need to think about your memory. You need to remember that you basically are working in the stack. Moreover, main is just one part, a small part inside of your stack. And you have the heap. Remember this distribution. Now, if you have this distribution in your mind and you start reading the source code, we need to visualize what is happening in the memory. I am creating a pointer. The pointer name is going to be head. The type for the pointer, and I put everything in red for you to remember. Struct and the name is the type. The both words, the two words together are the type. Null is a pointer. And if I go here, I have a variable, head. It's a pointer. It's not a struct. It's just one box to store a number, and that number is going to be an address. And it's inside of main. It's inside of the stack. It's not in the heap. So far, fine. I am going to use Malloc. I am going to use Malloc, and I am going to store something in head. Moreover, I am going to use Malloc to create something, and that something is size of the struct. And then a lot of arrows. a lot of arrows, head, arrow something, head, arrow something. Things are happening. Hopefully, remember this for a moment in your mind. And if I move here, what is happening is, number one, I use Malloc, and whatever Malloc do, I store the result here, like an address. And I need you to remember that when you use Malloc, you're using the heap. Whatever that Malloc did is here. Moreover, Malloc gives you back the address of that something. That is what you have after you use Malloc the first time. Head, the variable, is in the main. It's a local variable. It's in the stack. It's pointing to a particular address in the memory outside of the stack in the heap that is size of a node, therefore have a space for those two variables. And I need you to remember that something that we do when we have a pointer like head is, if I want to store something here, val, you're going to use both names, head and val. Option number one, you can do this dot and this asterisk as we have done before, but we need parentheses, and we need parentheses because we need to change the priority of the operators. I can play with this dot, asterisk, and parentheses, or I can have those two elements and use the arrow. The arrow, minus and greater than, they create this idea of the arrow. Why? Because this arrow, the pointer thing. The only way to use the arrow is having a pointer. If I create a struct node x in the main, if this one is a local variable, that one is going to be here, x with the two values. And if I want to access this val here, is x dot val, not with the arrow. Why? This is not a pointer. This is not a pointer. This one is a pointer, the arrow. If you continue reading the program, head arrow next equal Malloc and again, if you do Malloc, it's another struct outside of the stack. And you can continue as many times as you want. Obviously, head, next, val, head, arrow, next, arrow, val, equal 5, and you have the 5 there. Notice that you can continue using the arrows in the same way that you can continue following my picture. And as many times as you can do head, arrow, whatever. If you use the next, you can move forward. I need to remember to put an end to the list. The last element should be null. Head, arrow, the next, arrow, the next. If that one is going to be the last one, null. Or I can do equal to another Malloc and put something else and continue with the list, right? We did this before. Hopefully you copy paste the source code. Hopefully this is clear. When you run your program, this is what is happening. So far, good. Now, this is happening. But then I have methods. The first one of those, push. And I am calling push, and I am sending as a parameter head, and I am sending as a parameter a number, 2 parameters. Something that I need you to be aware is all this was because of main. Now you're creating another method. That other method is push. The methods have a different place in the stack. We are still in the stack, but in a different place. Now, I am sending as a parameter head, and I am sending as a parameter a number. 2 parameters that I am sending. Obviously, the method needs to receive those 2 parameters. Something important, parameters are local variables. If I am sending 2 parameters, something that I am going to have is 2 local variables inside of the stack. The only thing that I need to know is the name and the data type for the variables. And if I review push, I am sending an integer, and hopefully you agree with me, like, well, in order to receive the integer, you need an integer variable. That is something that you did in your introduction to programming class, right? Parameters. The only important thing here is, well, the first parameter is head, and the data type for head is a pointer to a struct. Well, the parameter should be a pointer to a struct. In terms of my picture, what I send is a number here. The second parameter, it was an integer. And in the first one, what I sent is the same thing that I have in head. I am sending it. Really, the value, the address, it doesn't matter. The important thing is, because this one is a pointer and is not null, this one is pointing to the same element that the head in main is pointing. Notice that I'm using the same name. This is head and this is head. I just did that for you. But remember, this is a local variable and this is a parameter. They can have the same name or different names. It doesn't matter. They are 2 different things, right? I am using head just to remember you that this is the same that this one. But this one could be used H or X or whatever. It's the name of a local variable. That local variable have an address because it's a pointer and is pointing to this place, the same place that the head variable in main is pointing. That is what I have. 2 methods, but working with the same data. Well, the same linked list. What is happening in the method? You notice another pointer? Current. We reviewed this in the previous lecture, but I have this new pointer current that is going to be equal to head. You can imagine what is going to happen. You're going to have another pointer pointing to the same node that the other 2. 3 pointers pointing to the same position. It is possible. No problem there. Now I have a while. And the while is basically checking if the next is different from null. If that is true, it's making current equal to current next. So it's kind of moving the value of current, and it's going to stop when current next is null. Hopefully you agree that the only thing that is happening in this loop is I am searching for the last element in the list, because the last element is the only one that is going to have null as next. If you think about the picture, what I did is a local variable, current. I make current equal to head. Therefore, I make this one pointing there. In some point in the program, I have this on the memory. And then I check, hey, current next is null. No, it's not null. Okay, then make current equal to current next. Whatever address is here, now it's going to be here. And again, we don't care about the number, but what is going to happen is that now this connection do not exist anymore. And now this one is going to be pointing there. And that was only one iteration of the loop. Again, the while is going to ask current arrow next is equal to null. Yes, current arrow next is null. This one is null. Okay, stop. Current arrow next null. Stop. Stop. Current arrow next not different from null. Condition false. Go out of the while. Continue the next line. I found the last element in the list. And what I do when I found the last element in the list? A Malloc. And as you can notice, a Malloc, and I store in current arrow next the new pointer, the new address. And then I just put the value and the null in the new elements, in the new next. Notice that I have arrow and arrow, two arrows. So you have this picture, and you are telling me that what you are going to do now is something like Malloc, and that Malloc is going to be stored in current arrow next. So that Malloc is here. Therefore, this one is not null anymore. And then the last two lines is something like this number, the 5, is going to be copied into current arrow next arrow val. Remember the two arrows? And finally, current arrow next is going to be null. You can imagine that this is the method add for a linked list. And you can assume that this work doesn't matter the size of the list, because always, the loop that I have there in push is going to move until this current is pointing to the element that have next null, until this current is pointing to the last element in the linked list. And when you have that, the only thing that you need to do is a Malloc connected here, and then adding to the new node a new value. And for that new node, that now is going to be the last one, the next is null. The method that you know as add. And if you want to be very, very specific, add at the end of the list. That's it. push. Push, thinking about a stack, right? Push and pop. Add, at last, linked list. New element. Important. Remember the picture in the memory. Map this source code with what I showed you in the memory. Now, this is just one method. I am sure that you have the opportunity to review the other. I have this pop. And at this point, you notice that I am sending as a parameter ampersand head. What is happening in the memory? Let's see. What you are doing, according with this story, is, well, somehow you have this method pop is a different space in the stack. You are receiving one parameter. That parameter should be a pointer because you are using the ampersand, but you are using the ampersand for head, and head is already a pointer. So the most important thing here, guys, is this one. The variable that I am creating here as a local, the parameter, it's a struct node, but it's a pointer to a pointer because I am sending the address of head. I am sending this, not the address inside. I am not sending as a parameter the address of this first node. I am sending as a parameter the address of this pointer. So what I have is this guy, a pointer to a pointer to the local variable in main that have the address of the linked list. I am not pointing directly to the linked list. And this is a big difference, right? A pointer to a pointer. Really? Yeah. If we review the code and we go to the method, to asterisk, pointer to the pointer, not a pointer to the data. Okay, something is going to happen with that pointer, whatever, but that is what I have. Now, what I am going to do, I have this variable, next node, it's local, it's a pointer. Something is going to happen, not sure what. And then asterisk head equal null return -1. Let's do those lines. Number one, you're creating a local variable. You're creating a local variable next node. It's a local variable. It's a local box inside of pop, inside of the stack. You need to remember local variables in the stack. Only Malloc allow me to go out. Okay, fine. Next, asterisk head equal null. I am checking if head is null. Can you help me? Who is asterisk head? Because head, I am talking about this variable here, right? And notice this one here is asterisk. I use the local variable. I am not talking about the head here or the head here. They are variables local in other methods. I cannot access them. I am working with my variable head. And again, you can change the name if you want. I am using the same used to point out the difference between the green one, the blue one, and the red one. Different variables in different methods. Anyway, who is asterisk head? What does it mean, the asterisk before a pointer? The arrow? Do you remember? When you put asterisk and the name of the pointer, what you want is to go to the address pointed by the pointer. But you mentioned that that is the arrow. Yeah, you use the arrow when you are using structs. The arrow represents the dot with the asterisk. The asterisk is the one that is jumping. But if you have an asterisk and a dot, you transform that to an arrow. But without the structs, like use pointer, the asterisk is the one that represents this jump. The asterisk is the one that represents go to the address. Can you agree with me that when I do asterisk head, what I am doing, what I have is the value inside of this box, the value inside of the address that I am pointing. Asterisk head is this 0xf in my example. Now, the first thing that I did is asking if whatever value is inside is equal to null. Why? Because if this one is equal to null, I do not have a linked list. I do not have one element either. Okay, 0xf or whatever is inside is the address of the first element. So that one is not going to be null. So I have a linked list, and at least I have one element. And this head is pointing there. Hopefully, fine. Now, asterisk head is not null. I am not going to return. I can continue. I can continue, and I am going to do this. What I am going to do. Next node is a local variable. I have it. It's going to be equal to asterisk head arrow next. Wait, are you mixing the arrow with the asterisk? Yes. You need to remember, asterisk is the jump. The arrow is just another jump with a dot. This is the arrow. This is the asterisk. So asterisk head arrow next. This is head. Asterisk head is this one. That one. Arrow next. Arrow next. Or if you prefer, instead of the arrow, asterisk dot to access the field. The jump is the asterisk. The dot is to access one of those two elements. Asterisk, jump. Asterisk, jump. The dot to select the element. You put together the dot and the asterisk, is an arrow. Arrow next. So asterisk head, arrow next. Here, asterisk, here, the arrow. And what you have is this value inside of this box. And what you want to do is to put this value here. Okay, this one is 0xc, whatever. And you want to put here 0xc. And in that moment, you have this next node pointing to the same place as this one. So you have this guy pointing there. Did you notice what happened when you copy a pointer in another pointer? Now you have two things pointing to the same place. Good, that is what I have. Now, next node is pointing to the second node. A variable, asterisk head, arrow val. If you follow the same idea, is okay, you are telling me that now you have another local variable here that is red val, and that one is going to be head, asterisk, arrow, but now with val. So if I have here a 1, I want to copy here the 1. Copy the value, copy the pointer. Fine. The important thing is this free asterisk head. Asterisk head. We already know what that means, and we want to do a free. Asterisk head is this 0xf, and what I am doing is giving the order free, and what I am passing as a parameter is this 0xf. That is what I am doing. And 0xf is this circle here. That is the data in the address 0xf. That is what is called head in the main. That is what is called asterisk head in pop. And when I do the order free, what I am asking is for this one to be deleted. Only that one? Yes, only that one. Because remember, the free start in this address, and it's going to remove the number of bytes that correspond to one element. How many? We talk about it, 8 bytes. I delete 8 bytes. I delete the circle. The circle represents that size. That is what I have now. So you deleted the first element of the list. That was the pop. Okay. I need to fix the list, right? Because I just delete the first element. I need to update the connections. The most important update, that one. Let's make asterisk head equal to next node. Who is asterisk head? This is head locally. But asterisk head is this one in the main. And what I am going to do is to change the value in a local variable in another method. I am going to change the value in the local variable head in main using the method pop. And what I am going to do is to put here this value, 0x, whatever. When I do that, instead of having this pointer that is pointing to nothing because I just delete the node, I just change that. This connection, do not exist because now I change the value. And now the value that I put here, change the pointer there. Remember, 0xc is pointing here. And I just copied this value here. So what I did is now this one is pointing there. And the next thing that happened is the pop return. And what happened when you return from a method? The most important thing that you need to remember is when you return, when the method finish, every single local variable is destroyed. The method just disappear from the stack. And that means you do not have this, you do not have this. The method finished. What the method did, the method delete the first element and update the connections that you have, update this head pointer in your main. Another method, do a change and update your data. That is what happened with a pop method. And if you think about it, is the remove method that you have for a linked list or a vector. Makes sense? Question for your exam, something to think about it. Can you imagine what I need to do here to have, instead of use pop or remove, something like remove all? This pop or remove, delete the first element. What if I want to remove all? What if I want to remove the first one and the second one and maybe the third one, all of them? And at the end, I want to have this head equal to null. Moving head equal to null is the easy part. The hard part is removing all of this, cleaning the memory. What is the implementation? What do I need to do to change pop to remove all? And that is something for you to practice. Good. Maybe you can work with that in the review. I don't know. Anyway, so far, questions? Yeah, I could agree with that. You can make a while loop with the pops. In some point, you have the solution.
Me?
Go ahead.
Do you need to like remove the head as well?
Yes. The only reason because you receive the head as a pointer to pointer is because you do not want to have direct access to the head until the end. The last thing that you do when you delete is to change the value in the head. But in the pop, you have another pointer that is your temporal head. Because remember, if you miss the head, if you lost the pointer to the head, there is no way that you are going to be able to access not only to the first element, but no element in the list. So you need to be careful with playing with pointers. Missing a value, losing a pointer is losing this string that is connecting you with the data outside. It's like the keys of your car, right? Anyway, the easy one, something that we reviewed before, the printing, and hopefully this one make full sense with the loop, and the loop until you have a current in null, and this current next that we reviewed previously, this pointer that is pointing to the next element until is pointing to the one that have a null in next, and this is the traversal, printing, adding, removing in a linked list. Hopefully easy. Copy, paste, and remember, practice for your exam. Now, the last thing that I need to talk with you, and we reviewed this here, but now I want to point out directly to that, is parameters to the functions. Parameters. You know what? Right now, we have two things that we can send as a parameters. Number one, and something that is very easy, we did this just some minutes ago, integers, primitive data. You can send as a parameters primitive data, and you know that you send copies of the values. The second thing is pointers. And at this point, my expectation is that you know that arrays, sending an array as a parameter is sending a pointer. You are sending the address of the first element. And you can send pointers or pointers to pointer or pointers to pointer to pointer or whatever. However, in Java, what you review is that there is two things that you can send as a parameters. The first one, primitive data. The second one, you didn't work with pointers in Java. You work with something else. Yes. And right now, I think we are ready to talk about, well, what is the difference between a pointer and a reference? Because so far, we have been working with them like the same idea, this pointing or referencing something. They are not the same, and I need to show you why. Yeah, you can use type def. I mean, you can define a new name for a data type, and yes, you can use that data type in the parameters. But remember, even if you're using type def, what you are really using is the type that is associated with that name. In our examples, we can do a type def and define cat, and cat is a new name for int. So you can use as a parameter a variable type cat, that is going to be okay, but really it's an integer. So really it's one of these. Or you can use type def to define dog, and dog is, I don't know, a pointer to a cat. So you can define a parameter dog, but that is a pointer to a cat, that is a pointer to an integer. So it's a very fancy way to define dog is pointer to int. Type def is used to make your programs easy to read or hard to read, depending on what you do. That's it. But you are not creating new data types. And remember that for the exam. So references, primitive data, pointers. Let's check. Number one, big parentheses, because I need this later. Before you use something, you need to define that something. So big parentheses, before you use a variable, that variable should be declared, right? If not, you're going to have a compilation error. Exactly the same rule is going to apply for the methods. If I have a method, foo, and inside of that method, I am calling another var, this is going to give you an error unless this method exists before this one. So you have noticed that, for instance, I always put the main at the end. So that main have the possibility to call other methods that should exist before. This is something different than what you have in Java. In Java, the order of the method doesn't matter because they are inside of a class. And for every single class, there is this kind of index. So you always know what the class have inside. Here, without classes, you need to have the method define it before you use the method. Now, sometimes what happens is tricky things like this example. What happens if I have a method foo that is going to call the method bar? Moreover, what happens if the method bar itself need to call foo? This one is fine because calling foo is before, but this one is going to give you an error because bar is not below. And it doesn't matter if I move this up, it's going to be an error. For those cases, what we usually do is forward declaration. What is forward declaration? You can put above of your method something like this. This is the signature of the method. The signature of the method is the data type, the name, and the parameters, and semicolon at the end. Think about this like giving a table of content to a book. So you put all the names and data types, returning and parameters for your method, and you do not need to put the body. And with this, you solve this problem. Every single time that you need a method, solution number one, the method that you're going to call should be above. Okay, you do not want to worry about which method is above one, or you have a situation like this one, just create this table of content. What is that? Just put type, name, and parameter for the methods that you are planning to have, and at the end, put the semicolon. With that, the computer knows all the methods that you are going to create. The computer knows that in some point you are going to have this method bar, and that method bar is going to be void and it's not going to have parameters. So with that, the compiler is going to be fine and it's not going to care that bar really exists below. Exactly. C++ is going to, but C need this. So use a solution if you have this problem. Another thing is, if you want to put the main at the top, like I want to have the main at the top, and this main is going to call the method X and the method Y, and I want to have the method X and the method Y below because I want to have that. I like to program first instead of bottom up. I want to work top down. You can do it, but you need to put above the main something like this. The data type, the name, the parameters for your method. Doesn't matter that you put at the end the semicolon, and then you can start working. Again, the table of content of the book, and then you can start with the content of your book. Big parentheses. The same thing apply with variables, apply with methods. Anyway, so parameters. Going back to the important thing. In parameters, I just need you to remember that there are formal parameters and actual parameters. Can you help me with the difference? Which are the formal parameters and which are the actual parameters? This 5 is a parameter, right? And this variable int x is a parameter, right? Parameter 5. Int x, the parameter. One of them is called the formal parameter. One of them is called the actual parameter. The parameter that is the variable, and the parameter that is the value for that variable. Formal, the one in the right, yes. The actual, the value, is a parameter. It's the one that you are sending when you do the code. Formal, the variable, the place in which you receive the data. So parameters, but just to be sure, what are we talking about? If about the value or about the variable, the formal and the actual, the variable, the value. Use another big parenthesis. Anyway, so examples of parameters. Number one, I can have a method and I can send a value like this foo with a parameter b. I can call foo and send a. A is this integer here. Can you agree with the result? If you look to this left part of the screen, it's like, let's see, I have two methods. Which one is going to be the first one to be executed? The one at the top, foo, or main? And at this point, you know, it's always main, right? So you start here. And the first thing that you do is a variable, and that variable have the number 2. And then you print the variable, you print the number 2. And then you call the method. And when you call the method, what is going to happen is another part in the stack. And you're going to have a variable, and this is A, and the other is B. And B is going to have a number 2, right? Because that is what you do when you send parameters. You copy this thing inside of this one, the 2 inside of B. And then here, you're going to print B, and you're going to print B, and the first time B is going to be 2 because that is the value that I receive. And if I change the value for B and I put a 10, the 10 is going to be in that box, the variable B. And when I return, I can print A again. And with A, nothing happened to A. It's 2. You know that from Java. That is the common behavior, right? Okay, this is values. The fancy name for this is a call to a method with parameters by values. The parameters are values. And when I say values, 2 different variables, 2 different values, nothing happened. Now, the other way, what if we transform B to a pointer? What if here, instead of sending B, like I did before, instead of sending the variable, I send the pointer? Well, if you do that, now you are working with addresses. You are sending parameters, but now we move from values to addresses. And what is going to happen is now you have this variable A, and you can put the 2 in A. You can print it. When you send A to the method, well, the method have a variable B, but that B is not for values. That B is for addresses. So if you have an asterisk here, you need an ampersand here. And what you're going to send is whatever is the address of this variable. And what you're going to have is this one pointing here, just like we reviewed before with the linked list. And if you print B, you are going to print the 2. You're printing asterisk B. You are going to print this. The asterisk is the jump. If you change to 10 asterisk B, you are going to stop the 10. Not here, but here. Asterisk B equal 10. You can print B again, and it's going to be 10. And you return to the main. And if you print A, Now A is 10 also. Values, address. And those two are clear because it's what we have been doing before. You have this in Java, but you do not have this in Java. What you have in Java is references. And this is the address. This is the one with pointers. This one is this one. I just copied this one here for you as a reference. 2, 2, 10, 10, the one with pointers. What you have in Java is what is called calls by alias. Alias is what you know as a reference. And I want your help. Can you notice the differences between this one, pointers, this one, references? In particular, I am giving you some circles in red. Can you notice what is happening inside of the circles? And in particular, in those 4 points? And in this point, the things become crazy because, wait, are you telling me that I can do an integer variable a, and that can be equal to a value? It's going to be a box with the value inside. That is a value. Are you telling me that finally I am starting to understand that you can do the asterisk between the data type and the name, and that represent that I want a pointer? And inside of a pointer, I can store an address. And I can get an address with the operator ampersand, for instance, like this. So if this variable here have an address, A, B, you can store that address in B, and that one is pointing to the value. Yes. But now, data type ampersand C, variable, pointer, reference. You create a reference with the ampersand in the middle of the data type and the name. What is a reference? A pointer. This C is going to store addresses. For instance, this C can store the address of B. Are you telling me that a reference is a pointer? So what is the difference between using the asterisk or the ampersand? One small difference. If you use the ampersand here instead of the asterisk, you can do that. Did you notice what is happening in that last line? Int ampersand C. When I put the ampersand, I am telling you, C is a pointer. It's not a value integer. It's a pointer, it's an address. It's going to store an address. But when I do equal A, automatically the computer is going to detect like, okay, A is a variable. You are making an equal with a reference. You do not want to store the value in C. What you want to store in C is the address. I am going to give you the address. Same result. two different notations. Asterisk for the pointer, ampersand to get the address, ampersand to create the variable. You do not need anything extra to get the address. This is a reference. Why? What is the difference? A very important one. Think about this. I have this variable x equal 5. I can create a pointer y equal to the address of x, y pointing to x. And what about asterisk y plus 1 equal 7? Can I do this? Yes. Where is going to be the 7? There. Variable plus 1. It is good to do that. And hopefully at this point you agree with me, like, no. Yeah, just like in an array. In fact, you can do y in the position 2 equals 7. Really? Yeah, it's a pointer. Arrays are pointers. Y in the position 2 equals 7 is going to put another 7 in what should be the position 2 of the array. That is not yours because you do not allocate that position. You are using memory from other programs. This happens with pointers because you can do these arithmetic operations with pointers, because you can play with pointers like index. That is the power of the pointers. You have an address and you can add or subtract numbers from the address. And therefore you can access positions that are before or after the address. Sometimes you want to do this, but this is dangerous. I mean, for a programmer that have no idea what he's doing, you do not want to risk these places. So what we do, instead of this, pointers, with the power of adding, subtracting things, the second option is, well, let's create references. Reference, like this one. And I am going to do this one equal to x. This is just like this. And C is going to be like a pointer. And it's going to be pointing to x. I am doing that here. I never use here the asterisk. I never ask for the address. That is happening automatically. Just because this one is a pointer, that one is a reference, that one is a place for addresses. This one is going to store the address. Now tell me, what is going to happen if you do C equals C plus 1? What are you going to print if you print C? And the power of the references is, if you do C plus 1 here, what is going to happen is 5 plus 1. And you're going to store that result in C. What is going to happen is you are going to store a 6 there. You're using this in the same way that you can do asterisk y equal asterisk y plus 1. The difference is that with pointers, you can also do y plus 1 And we can agree that this one is adding 1 to the address. This one is adding 1 to the value pointed by the address. With references, that is the only thing that you can do. C plus 1. The only thing that you can do with the reference is play with the value. There is no way that you are going to be able to change this pointer and make this pointer to point to any other place that is not the address of the variable. You cannot add 1 to the pointer. If you add 1, automatically the computer is going to add 1 to the value inside of the place that you are pointing. The references are something like secure pointers, something like the same functionality of the pointers, but without the possibility of playing with the address, without this freedom of choosing if you want to add 1 or anything to the address or to the value. Moreover, you do not need to remember the asterisk and the ampersand. The asterisk, when you work with references, the only thing that you need to do is the ampersand between the data type and the name, and that's it. You never need another ampersand or an asterisk. You do not use asterisk with references. Only one symbol, only in the declaration, that's it, is a reference. And it works like a pointer without the power of the pointer. Make sense? Excellent. So I am pretty sure that you can get the idea with the example. Only if you compare, the results are the same, but here you are not going to find any asterisk. Moreover, the only thing that you watch is this ampersand, and that's it. Please review this. You can review this also in the review. And talking about the review, Jacob.
Yeah, just wanted to bring up, so hopefully by tomorrow morning, I'll have a Muddiest Points survey up and posted on Canvas. If you haven't already seen it, I did post like a discussion post for where people could get on there and ask exam questions. So I'll be posting a Muddiest Points survey on there latest by tomorrow morning. So you guys can fill it out anytime on the 7th. And that'll give me a chance to prepare a brief presentation based on the stuff that you're confused on. And we're going to be reviewing a whole bunch of material on the 8th. So just keep that in mind, keep a lookout for that. And yeah.
Good. Guys, you have the review, the next lecture. I am giving Jacob some questions from the exam, not all of them, but he knows some of the questions. He's going to show you some of the questions, but my recommendation from today to the next lecture, please review all the material, all the lectures, including this one and before, and be prepared to ask questions. Okay, see you guys. Thank you.